Hello, everyone. My name is Mete Atamel. I am a developer advocate at Google Cloud in developer relations team. I've been at Google since 2016, so that's 9+ years. And I count my talks, so where I talk and how many talks I did. And today, it is my 400th talk at NDC, which makes me really happy because NDC is one of my favorite conferences, and it's great to be back. Today I'll be talking about large language models, but not so much about how to use them, but rather how do you know what you get from large language models is actually good? What do you measure? How do you measure? How do you secure them? What kind of tools you can use? So I looked into this area for a little bit, and I learned some tools and some metrics and things like that. So I just want to share with you what I learned. If you want to follow me, this is my Twitter. I also maintain a blog where I talk about application development with large language models lately. And if you want the slides, if you go to speaker deck, I already have the slides up there. And I'm going to share these links at the end of the presentation as well. All right. So I think it's very easy to get LLMs generate some content. And it's literally a single API call. And let me just show you a quick video and also look at the code just to make this point that it's actually very easy to get started with LLMs. So here I am in Google Cloud, in Vertex AI, which is the AI part of Google Cloud. And let's say I have this video from one of my favorite places, Rio. And let's just take a quick look. So you see it's a video with some music, some explanation.
To Rio de Janeiro, the marvelous city. There's the Rio everyone
Right. So if you have this kind of video and then you want to analyze this using LLMs, you can basically just pass the video and then you can say, okay, chapterize the video for me, break down the key events and highlights, and then give me this information in the JSON format, right? And then you can choose the model you want. Here I'm using Gemini 2.5, which is the latest model from Google. So if you run this, within 10 seconds or so, I guess, because it's a video, so we need to analyze it a little bit. But now, and also Gemini 2.5, it's a thinking model, so it takes a little bit of time to think and gives you its thinking as well, so you can actually see what it thought about and how it got to its output. But in the end, you get this JSON with the chapters and then what happened in the video, right? And then if you look at the code, it's Python, sorry, it's not C#, but you can do this in C# as well. You create a client here, then you point your video, and then you pass your prompt and the video as a content. And then there's some configuration. You don't even need to set this, but you can set them if you want. And then finally, you just call client generate content and with the model, with the text and the video, and then you get the output streamed to you, like as we see in here. So as you see, it's literally just setting up some configuration and then sending it to the LLM with a single API call. And then with that, you get video analysis. And you can do many more things like that. So it's easy, right? But what's very difficult is that how do you make sure that what you're getting back is actually good? How do you quantify that? And how do you know? And good LLM output can mean different things. Maybe you are looking for a certain structure in the output, right? You want JSON, and maybe you want a certain structure to that JSON. So if it follows that structure, it's good for you. Maybe you want to make sure that the output is actually correct. You don't want LLM to hallucinate, and you want to make sure that whatever it's giving back to you is actually factually correct. Or maybe you want relevant information, because maybe the output is correct, but if I'm asking about the weather of Oslo, I don't want to get the information about the weather of London, for example, even though it's correct. I also want to make sure that the output is relevant to what I asked. Or maybe you want it to be grounded. So you have some data, your private data, and you want to make sure that the model is responding from that data instead of just hallucinating things, right? Or maybe you want to make sure that the LLM doesn't say things it's not supposed to say, or maybe it's using tools, and we'll talk about tools a little bit later, and we want to make sure that those tools are being called in a certain order, or maybe something else, or maybe a combination of these things, right? So what it means for the output to be good is actually something that you need to define, and maybe it's a combination of these things. It's not so obvious. And if you talk about structured outputs, by the way, this used to be a problem when large language models came out 2 years ago. You would get any kind of output. It would be free text, markdown text, JSON, and also it would be things like sometimes you would get JSON, but then there would be a small error in the JSON, so you couldn't parse it properly. So you had to always double check what you get back and put code around parsing logic to make sure that it's not going to throw up some error when you're trying to parse it. But thankfully, the latest models, they all provide what's called structured outputs. So what you can do is basically you define a class, a Pydantic class is called in Python. And then let's say we have a recipe class. It has a name and description. These are strings. And then it has ingredients, which is a list of strings. And then when you generate content, and let's say you want to get some popular cookie recipes, in the configuration, you can specify that the output you want is JSON, but also you also specify that the schema is this recipe class, right? So by doing that, you are basically telling the LLM, I want the output to be JSON, but I also want it to make sure that it follows this schema, which is a class. And these classes can be nested, so it can be much more complicated than a single class. So if you do this, then what you get back is basically the format, the JSON format that you expect, and you can parse this and you can work with it in your applications. So if all you're looking for is structured outputs, then that's kind of a solved problem with large language models. Most of them, they support this, and you can just specify what you want, and they'll give that to you. But then, how do you know the rest of the output is good? Well, you need to measure. But then at this point, the question becomes, what do you measure and how do you measure it, right? And that's what this talk is about. So I'll tell you what I know in this area. And if you work in this area as well, please come and talk to me afterwards. I want to know what you're using and what you're measuring as well, because I think it's a very open area right now. So I'm always looking to learn more. Now, in terms of measuring LLM outputs, you're going to use an LLM evaluation framework at some point. And this depends on where you are. For example, on Google Cloud, there's Vertex AI, the AI platform. And Vertex AI has something called Gen AI Evaluation Service that you can use to basically measure the outputs of your LLMs. So if you're on Google Cloud, it probably makes sense to start with this one. But there are others. There's DeepEval, which is an open source evaluation framework. You basically write your evaluations in Python. There's another one called RAGAS, which is more for Retrieval-Augmented Generation, and it provides metrics for that. There's another one called Promptfoo, which is a security framework, but it also does evaluation as well. And it's mostly YAML-based, which I don't like so much, but it has some benefits as well. There's another one called TrueLens, and there's many more, actually. So these are the ones that I tried myself. So as you see, there's quite a bit of choice here, right? And when you look at these frameworks, at some point, you're going to decide on, OK, what am I going to measure? So you're going to look into metrics. And when you look at DeepEval's metrics, for example, there are metrics like GEval, which is based on a paper that you can read about. Then there are usual things like contextual precision, recall, tool correctness, so on and so forth. Now, if you look at Promptfoo, it has similar metrics like GEval and context recall and stuff like that. But then it has other things like model-graded close Q&A. I don't even know what that is. Then if you look at RAGAS, then they have Retrieval-Augmented Generation related metrics mostly, but they also have things around agents and tools. So at this point, you'll be thinking, which one should I use, right? And it depends. I mean, you can choose the framework and then look at what you can use to measure with that framework. Or if you know what you are measuring, then you can see if the framework supports that metric. And I don't think there's a right answer. Or maybe sometimes you do both. Maybe you use DeepEval for some of the basic metrics, but if you are doing something with RAG, then maybe you also use RAGAS for that. So maybe it's a mix and match. But when we look at metrics, there's this good blog post from confident AI people. These are the people behind DeepEval that I'll talk about later. And there's a good blog post on different metrics, and I like this diagram. But basically, the metrics, they kind of fall into two categories. The first one is what's called statistical or deterministic metrics. So these are metrics where you pass in your text that you want to measure, and then you pass in a reference, and then they give you a score, okay? And this score is not going to change. So if you pass in the same text and same reference, you will always get the same score. So they're deterministic, and that's where you can start with, but they have problems that we'll talk about. And then there are also model-based scorers. And the idea here is that you have your output, and you use another LLM as a judge. So you use another LLM to measure the output of one LLM, right? So you use LLMs basically to do the scoring. And we'll talk about both and the pros and cons of each. And there are also apparently some scorers in the middle where they're based on some statistics, but they also use models to derive those statistics. I haven't looked into them too much, but I know that they exist, and maybe at some point I will do a deeper analysis on them. But these are the kind of the two top level buckets that you have. And most people start with deterministic or computational metrics. These are simple things like, for example, you can do simple things like equals, contains, and it starts with. This is basically the usual string matching that you could do. And you don't even need a framework for this. You can just use like your language to do this kind of matching if you want. But the frameworks, they also support this. Then there are other metrics like BLUE, for example, which measures how closely the response matches with the reference that you have. And it gives you a score. Then there's another one called Rouge. It's similar to BLUE, but it's for summarization. So if you have a text that you want to summarize, and then if you have a reference summary, then Rouge can tell you how close the output summary is to that reference. And there are others as well. But the problem with these metrics is that, first of all, you need a reference data set. So you need to have something to compare to. And if you have that, you can use them. But in some cases, you don't have a reference data set. So then you're stuck. And the second and bigger problem is that these metrics, they kind of fall short in capturing the language semantics. Language is very complicated, and certain things we take granted. Like when we look at it, we understand what it means. But these scores, they don't capture that all the time. And they become, they are useful at the beginning, but then pretty soon, if you're working with large language models, they kind of become useless. And actually, let me show you an example. In Vertex AI Gen AI evaluation servers, these are called computational metrics because you compute them. So let me just show an example of how that works and how we can measure them. So here I have a computation.py example. And let's say, normally you call your LLM, get the responses for a certain question. But let's assume that we have the responses already. So we call the LLM, we save the responses, so we have these responses that we want to evaluate. So the responses I have is, hello, how are you? I'm good. The cat lay on the mat, right? So these are the three simple responses I have. Then with computational metrics, you need a reference. So let's imagine that these are the references that I have. These are basically the perfect output that I'm expecting. And as you see, like the first one is the same. The second one is like, the reference is I'm good, but the response is I'm good. So it's almost the same, but slightly different. And the third one is the cat sat on the mat, and the response is the cat lay on the mat. So it's almost the same again, but slight difference in meaning. So what you do is that you create an evaluation data set with the response and the reference, and then you create your metrics, what you want to measure. So you can do this is Gen AI evaluation service specific, but it's pretty much the same in most frameworks. So here I'm doing an exact match. I'm also measuring the BLUE and the Rouge, and then Rouge also has different flavors of it. Rouge 1, Rouge 2, looking at like combination of words, but let's just stick with the basic one. Then I run my task with the metrics and the data set, and then I will get the results and I'll just print them out. So let's actually run this and see what we get. And now this is running it in Gen AI evaluation service in Vertex AI, and pretty soon we should get a response, and then we'll see how computational metrics are not that great. So if you look at the answers, for example, for the first response and reference, the exact match is 1, because it matches 100%. Then blue score is 1, rouge score is 1 as well, so it makes sense, right? But the second one, responses I'm good, references I am good. The exact match is 0, so because it's not an exact match. But the blue score is also like 18%, right? So the blue score thinks that it's also not that close, because it's a short sentence, and then in a short sentence, when you have am versus apostrophe am, it's kind of different, right? So that's why it's thinking that it's different, even though we know that as humans that this is actually the same thing. Rouge says it's 66%, so it's better. And the last one, the cat lay on the mat versus the cat sat on the mat. Again, it's almost the same thing, but the blue says 48% and the rouge says 83%, right? So maybe rouge is better, but at least for blue score, I wouldn't use that to see if the output I'm getting is good or not. So that's the problem with computation or deterministic metrics. Now, at some point, you'll move into model-graded metrics, and there's many of them, depending on what framework you use. So you can do similarity search. You can do you can look at answer relevancy. So given a question, how relevant is the answer? You can see summarization, how good is the summary? And the idea here is that you have the output of one LLM, and you will use another LLM to kind of measure the output with these metrics. Now, of course, the question you have right now is, can you rely on one LLM to grade another LLM? And then, according to this paper, you can get the link from here. The answer is yes. Like 80% of the time, actually, one LLM is very good at kind of measuring another LLM because, and if you read the paper, you'll basically see that because you are giving LLM a strict script to follow and also a rubric and a scoring rubric, stuff like that. So because it has really strict instructions to follow and text, with that, it can actually do a pretty good job. So according to them, they're as good as humans, because even human evaluators, they get it they agree 80% of the time, basically. So for that model-graded metrics, I mean, you can use, again, Promptfoo or DeepEval. So let me show you a couple of examples from both. So if we look at, let's look at Promptfoo, for example. So in Promptfoo, you define your evaluations in YAML. So you define which models you want to test against. So these are the two models I'm using from Vertex AI. And then you also define which models you're going to use for model evaluation. So here, I'm using Gemini 1.5 and 2.0 Flash. These are the models that I want to test, but these are the models that I will use for evaluation. So this is the model, this is the judge model, basically. And then you write your tests. The first one, they have deterministic metrics as well. So in this case, for example, I'm asking the question of, what's the capital of Cyprus? And I know the answer is Nicosia, so I want to make sure that the output contains that. So I'm basically doing a string matching. So if you want to do that kind of stuff, Promptfoo allows you to do that, and there's many others that you can use. And then you can also do model-assisted metrics. So in this case, for example, I'm asking what's the weather like in London generally. I mean, we know the weather in London is never great. Well, I shouldn't say never, but it's usually not great. But the question is, how can we say that? And you can say that in many different ways. You can say it's not good, or it's rainy, or there's no sun, whatever. But what you can do in those cases is that you can do a similarity match, and then the value that we want to match to is mild and rainy. And then, of course, with any similarity match, you need to have a threshold. So in this case, we chose 70% as the similarity threshold. And then when you do that, Promptfoo will basically use the other model to kind of see how similar the output is to what you have here, right? So once you have this, you can say Promptfoo eval and point to your YAML, and then this will run both the deterministic metric and the model-assisted metric against the two models that we specified, and then you will get an answer, and then you see that the first one and this so the deterministic one passed for both, but for the other two, they failed because the similarity is 53% instead of the 70% that we specified. Of course, you need to play with these, and you need to make sure that the value that you're matching and the threshold kind of makes sense. So there's no right answer. You need to play and see what makes sense for whatever you are trying to test. So that's how Promptfoo works. I like this. I mean, it works, but at the same time, I don't like so much about YAML files and trying to define my test in YAML files. In DeepEval, you can do this in a more unit test kind of way. For example, so now I switched to DeepEval. And DeepEval has a lot of different metrics, but let's pick one. In this case, I'm picking the answer relevancy metric. The answer relevancy basically looks at the question and measures how relevant is the answer. So if the question is, how is the weather in London? I want to get an answer on that. I don't want to get an answer on something else. And the way this works is that first, this is the model I want to test. This is the model that I'm going to use as the evaluation model, so also judge model. Then here I'm creating my LLM client. And then this is my prompt, why is sky blue? Then I call my LLM with the test model. I get the output, so the LLM tells me the answer. Then I need to evaluate it, so I create a test case with the input, with the prompt, but also the output. And then I need to create my evaluation model. So this is the evaluation model. And I need to create my metric. So in the metric, in this case, answer relevancy metric, I pass in my evaluation model. Again, we need to pass in a threshold. So in this case, I'm saying 80% relevant. And then once we have the metric and the test case, we just basically do an assert, kind of like doing an assert in a unit test. But in this case, we're actually doing an evaluation and seeing if evaluation passed the threshold, basically. So that's how DeepEval works. And then if we, let me see where this is. So if I go, if I go here, DeepEval test run, answer relevancy. So this will run the test, and then it will give the results, and it will also tell us if it passed or failed, and it will also give us a reason why it passed and failed, which is very useful when you're trying to figure out why it got the score that it got. So let's see if this works. All right, so we got the result. And if you look at it, so the score is 1, which meaning it's 100%. And then it gives us the reason. The score is 1 because the response is a perfect and concise explanation of why the sky is blue. Great. So that seems to work. You can do other things like, I'll show you one more before we move on from DeepEval. Let's say you want to do summarization. So you have this text that you want to summarize, but you want to make sure the summary is good, right? What you can do in DeepEval is, again, basically the same kind of thing. You create your test case, you create your evaluation model, but the difference is that in this case, we are creating a summarization metric. And then in summarization metric, you can give some assessment questions. And the model will use these questions to determine if what it got from the other model is actually a good summary, right? So it will use these as kind of the questions. Are these questions answered or not, basically? So if you run this again, we'll get a score, and then from there, you can see if the summary is good or not. And again, there's a threshold that you can play with to see if the test passes or fails. So that's how DeepEval works. And then when you're dealing with large language models, at some point, you're going to build what's called a Retrieval-Augmented Generation. I won't talk about what Retrieval-Augmented Generation is in too much detail, but all I'll say is that it's a way to ground LLM with relevant information from your own data. So if you have, let's say, PDF documents that you want to use to ground the LLM, you take those PDF documents, break them into smaller chunks, put in a vector database, and when the user asks a question, you retrieve the relevant chunks and provide that as prompt, as context to the LLM. And with that, the LLM can answer questions about your PDF, and it can also answer in a more focused kind of way. So it hallucinates less because it has more context about your PDFs. So that's what RAG is. And in RAG, you typically have two parts to RAG. One is the retriever part, so the part that retrieves the relevant documents. And then once you have the relevant documents, you pass them to the LLM as context, and then the LLM generates output from that context. So that's the generator part. So for each part or RAG, there's different metrics that you can measure. And if you want to measure, like I mean, if you want to measure your RAG pipeline separately, like retriever and generator, it makes sense to measure them separately, right? So let's look at what these metrics are. So the retriever metrics, there's three of them. The first one is context relevance. So given the question, how relevant is the answer? The second one is context recall. Did we fetch all the relevant information? The third one is context precision. And that measures basically whatever we fetched, are they in the right order? Because you want the most relevant thing to be at the top versus the least relevant thing. So we want to make sure they're in the right order. So those are for the retriever metrics. But then for generator, you can check answer relevance. How relevant is the output to the input? And you also want to check what's called faithfulness or groundedness. This is about, does the output actually align with the context? Because you can give context to the LLM, but it can actually choose to ignore it altogether. So you want to make sure that whatever the context you are giving to the LLM, it actually follows that and it answers from that context. As you see, these two, they have a star because they require an expected output. So you need to have a reference output for you to be able to calculate them. If you have them, great, you can calculate them. If not, then you cannot. And because of that, what people have been doing is that they basically just measure context relevance, answer relevance, and faithfulness. And this is called RAG triad, basically. And the way this works is that you have your question. Then from the question, you get the context, the relevant documents. And then from the context, you get a response, right? So context relevance basically looks at, how relevant, how the retrieve context is relevant to the question. Then groundedness looks at, is the response supported by the context? And then answer relevance looks at if the response is actually relevant to the question. So by measuring these three metrics, you can get a pretty good idea of how good your RAG system is doing. But you also don't need reference data because you're not measuring the context precision and recall. But this is looking at your RAG system as a whole. Instead of looking at it in pieces of retriever and generator, you're looking at it as a whole. So that's what RAG triad is. And you can measure this in many different ways. Again, it depends on the framework that you're using. For example, DeepEval, I'll show you that again. In DeepEval, all these metrics are available. So you create a test case. Let's say this is your input, this is your output that you get from LLM. And you also need to find a way to get the context from the LLM. So what context it retrieved. And most models, they give you this information. So once you have that, you can add that in here. And then you create your metrics, answer relevancy, faithfulness, contextual relevancy. And you create your metrics array from that. And then you run your test case. And you'll get a result. Of course, if you want to do separate retriever and generator, you can do that. So you can basically just test the retriever. That's how you would do that. But if you want to test just the generator, you can do that as well. Let's see what else we can do. And I have examples of showing how you can set up a RAG chain and how you invoke that chain, how you get the result back, and then how you run a test case against that. So the end-to-end kind of test. So I have that here if you want to run it later. But typically, what you would do, you wouldn't just run this against a single question. So here we are asking a single question. What you would do is that you would run this against multiple questions. So you have these multiple prompts that you want to be answered correctly. Then you create test cases for each. Run through the whole thing basically in a loop, and then get scores for that, and then you can look at those scores afterwards. So all of this is available on my GitHub that I will share at the end of the presentation, and you can go and take a look. I won't go through in detail, but as you see, DeepEval gives you all the metrics that you need to do this kind of thing. Now, of course, if DeepEval doesn't do this, it does this, but you are using something else, you can also measure these on your own. For example, I am using Google Cloud's Vertex AI Gen AI service, evaluation service, and they don't have this metrics by default, but I can define them. So here, let me see how I define it here. Here I'm basically defining, they call this point-wise metrics, meaning you're running against a single model. So here I define my answer relevance. This is my criteria. So I'm basically explaining what I'm looking for, and then I'm giving it a rating rubric that it should follow from 1 till 4. So that's answer relevance. Then I define context relevance, same kind of thing. And then groundedness. So check the context and response. Check to see if the response is supported by the context. So I'm giving like some simple instructions to the LLM, and with that it can measure groundedness for me, giving the score that I need. And if you look at it, at the end of the day, all of this basically gets turned into a prompt that gets sent to the judge model, and judge model will use that to do the evaluation. And I did this, and I ran it, and it does pretty good job, similar to DeepEval, using a judge model. So it is possible to actually build these yourself as well pretty easily. If the framework that you're using doesn't support it, it's easy to do that. All right. So that's RAG. And then recently, we started having things like tools and agents with large language models. So tools are basically functions that can be called from the LLM. Like let's say you want your LLM to answer questions around weather, or you want your LLM to answer questions about stock prices or something like that. You can provide the model with these APIs and tell the LLM these are the functions that you can call, and the model will basically, well, the model and the library that you use to talk to the model will make these calls and get that information and use that. And this allows you to basically augment LLM with more recent data. So that's what the tools are. And agents are basically a combination of multiple tools and decision making. So if you are combining multiple tools and also a decision making on when to use those tools, then that kind of becomes an agent. And for each, you have different metrics. So for tools, for example, you can check things like, is the tool call valid? Like, should the tool be even called? Maybe you don't want that tool to be called. So you can check if the tool call is valid. If it's called, does the name match, or does the key of the parameter match, or the key and the value match? So there are things like that that you can check. On the agent side, it's similar kind of thing, but in agent, what you want to measure usually is first, like agents, they call multiple tools, right? And that those tools can be in certain order. Sometimes you want the order to be in a certain order. Sometimes you don't care about the order, and you just say, okay, just make sure you call these tools, but I don't care about the order. So that's called trajectory, and there are metrics for that. So does the trajectory match exactly to what I want, or is it in this order or any order, so on and so forth. So you can measure things like that as well. And the Vertex AI Evaluation service have metrics for these. So I won't run this, but I'll just show you how they look, so you have an idea. I think we look at this. What else? RAG-eval. Tool metrics, yeah. So if you look at, for example, this one, let's say I have this reference. So what this reference says is that I want to make sure that this location to lat long, location to latitude and longitude function is called with the location of London, okay? So that's the tool that I want to make sure that it's called, and I want to make sure that the location is actually London, right? So that's my reference. And then let's say you get these responses. So the first response is no tool is called. The second response is, the tool is called, but something doesn't match here. Let's see, the name doesn't match, I guess. The third one is the city doesn't match, and the fourth one the value doesn't match. Stuff like that, right? So if you have these kind of responses, then you can do an evaluation task and you can pass these metrics, and then you will see that you'll get scores basically 0 and 1. If it matches, it matches. If it doesn't, it's 0 and 1. So that's tool use. And if you look at the agent use, well, I also forgot to mention in agent, you care about the trajectory of the tools, but you also care about the output, the response. And the response is basically the same. Like the response is basically like calling the LLM and getting a response and looking at the response. So it's similar in that sense. But for trajectory metrics, let's look at this one, for example. So let's say, first let me look at a reference. So here, I want to make sure that my agent calls, again, this location to lat long tool with location London. And then once it has the London latitude and longitude of London, I want it to call this other function called lat long to weather with the latitude and longitude, right? So that I can get the weather information. So that's the reference that I have. And I have the same for, say, Tokyo and others. And then if we have this is the predicted trajectory, meaning this is what I get back from my agent. Here, for example, if it's a perfect match, then this is what you would have. But then maybe here you have the location mismatch, so location is Paris instead of London. Here we have another one where we call the right functions, but then we have an extra one that shouldn't be there. And then here they're called in mixed order. So you have the extra tool, and then you also have the functions called in mixed order, right? So if you have stuff like this, then these metrics basically that I define here, exact match, will catch that kind of stuff. So you can run this, and then again, you will get 0 and 1 depending on what you have. And if you look at response, so if you want to basically ultimately look at the response of the agent, so let's say you have these prompts, you get these responses, then basically, I mean, you just define your metric and then get the response and then just measure that. So it's like measuring the response of a large language model, basically. There's nothing special about it. But if you want to measure both trajectory and response, it really depends on the agent framework that you're using. But the way you would do in Gen AI evaluation service is that, first you define your prompts, then you define your reference trajectory that you're expecting. So this is what we expect. Then you define the metrics. So these metrics, so this one is for the response, and this one is for the trajectory. So I'm looking at both, both the output and also how it got there. And then what will and then the important thing is then I also pass in this runnable to my evaluation. And what this will do is that it will basically set up my agent framework that I'm using, and it will make the calls and then get the results and parse the results. Okay, so the way you would do this is that I'll go back up here. So here, I mean, I'm not doing this here because it depends on the agent framework that you're using. But basically, you will get the prompt, and at this point, you will set up and run your agent code. So that depends on your framework. And then once you get the output from the framework, then you call another function to put that into a format that the evaluation framework expects. So here I'm just doing a dummy output, but basically you get the response, so you put that in under response, and then you also get the trajectory, and you put that under predicted trajectory. So you kind of massage it and put it into this format, and you bring it back, and then that will run it against the evaluation framework and give you the result. So it's a little bit of work, and we'll try to make this easier in the next iteration. But that's basically how you would do agent evaluations. All right. But then, as you might know, the large language models, they are nowadays multimodal. Like they can generate, images and audios and as outputs, right? So how do you evaluate those? Because most of the stuff that I show you they are text-based. Well, this is kind of a new area, and there's actually something called Gecko now. It's an autorator for text-to-image generation, and there's actually a blog post on this that was just published. I'll just show you the idea of how that works. The way this works is that, let's say you have this prompt call, and you're saying, give me an image of a streaming cup of coffee and a croissant on a table, right? That's your prompt that you use to generate an image. And that gives you this image. Now you want to measure, like, how good is this image? Like, is it actually what we want? And what Gecko does is basically looks at the prompt. It's a little bit hard to see, but it looks at the prompt, and from there, it generates some questions automatically. So it says, okay, this is streaming cup of coffee and a croissant on a table. So it comes up with these questions like, is the cup of coffee streaming? Yes or no? Is there a cup of coffee? Is there a croissant? Is there a table, right? So these are the questions that the autorator generates with the yes and no. And then it looks at and scores them, basically. So if the answer is yes for all, which we've seen it from the image, then the final score will be 1. And this blog post talks about how to set this up. This is supported in Gen AI evaluation service as of today. I haven't tried it myself, but it's because it literally just got published, like, when was it? They don't have dates, yeah, May 14th, so today is 22, yeah. So I had a week to try it out. I haven't done it yet. But basically, this is how, one way of, like, kind of trying to look at image generation and see if that image is actually good. And I'm sure there are others. All right, so I have 20 more minutes, I guess, okay. So yeah, so we kind of have an idea on, like, what to measure and how to measure, kind of. But at the same time, like, we still need to worry about, like, bad inputs and bad outputs, right? The users can give us bad inputs, and then the LLM can give us bad outputs. So we need to detect and block them. And actually, there's a top 10 LLM applications security problems, and these are the top 10 in 2025. So if you go to this link, you can actually see them and read more about them. And Promptfoo, they actually did a good job of explaining these and also telling you how you can stop them using Promptfoo. And I think I have the link here. So if you look at this Promptfoo link, they basically go through each security problem, and then they give you ideas on how you can kind of prevent them using Promptfoo. So it's very useful if you want to take a look. But basically, you will need other frameworks to do this kind of checks. Security frameworks, I mentioned Promptfoo already, which is an evaluation and security framework. There's another one called LLM Guard that sits between your application and LLM and does input and output controls in the middle. And then there's another one called Guardrails AI, and I'm sure there are more, but these are the ones that I tried. And just to show you a couple of examples with Promptfoo, for example. So in Promptfoo, you can do what's called a red team testing. So you can generate security tests and run them against your LLM. And the way you do that is first you define a Promptfoo configuration file. And in here, you say how many tests you want per plugin. So in this case, I'm going to run one test. I'm going to generate one test per plugin. And the plugin is different kinds of things that you want to security test. So you can, for example, have tests around PII. You can have tests around hallucination, hijacking, politics, and there's others probably that you can enable. But here I'm just enabling a couple. And then once you have this, this generates a red team file, and I think I have it here. Yeah, and then this file you can think of it as like the tests that are being generated by Promptfoo for you to run against your LLM. Okay, so you see there's going to be a bunch of tests doing different things depending on which plugin you enable. And then you can go to Promptfoo and then run that red team file, basically, with all the tests. And then you see that some of them passed, some of them failed. And then you can basically look at which ones are failed. For example, this one failed because the output was revealing the full name and email of the person. So we don't want that because that's personal information. So it fails, and then we can go back and fix that and then run it again. So Promptfoo helps you for that kind of stuff. What was the other one? The other one I want to show you is LLM Guard. So in LLM Guard, let's see, where is that? Yeah. So LLM Guard has these input controls and output controls. They're basically scanners that sit in the middle and check things that you want to check. For example, let's say you don't want to allow people run pass code as part of your prompt, right? So let's say I have this prompt, which is some Java code. Then I can create an input scanner with ban code, and then I will pass my prompt through that scanner, and then I'll see that the scanner will tell me that the prompt is not valid because it contains code, right? So I can ban code if I want. I can ban topics. For example, here I'm saying I want to ban topics on politics with this threshold, and then the input scanner will look at the prompt. Here we are talking about the Prime Minister of UK, and it will ban that. You can do similar things on the output scanners. So let's say you don't want your LLM to have gibberish. You want to make sure that it actually says something meaningful. So you can have an output scanner with gibberish, and then you can pass the output from LLM and make sure that it's not gibberish. Or you can even block languages. Let's say your LLM needs to answer in French. You can have an output scanner for that. And then if the output is in English, then it will be blocked because it's not in French. And you can also do what's called anonymize and de-anonymize. So let's say you have this prompt where you are asking LLM to make a SQL insert statement, but you're also passing some personal information. You're saying the name of the person is this, the email is that, with the IP address. So there's a lot of personal information here. You don't want to pass that to large language model because you don't know what's going to happen to this information. What you can do is you can create an anonymized scanner and then pass the prompt through that anonymized scanner. And then what you would get back is this sanitized prompt where the email and the phone number and credit card and so on and so forth is redacted. Then you pass that to the LLM with that redacted information. Then the LLM will respond back with the insert statement, but with the redacted email address and so on and so forth. And then you take that and pass it through output scanner, the anonymized scanner. And with that, you will get back the original user, and then you can use that in your application. And the idea here is that you are basically masking your personal information, sending it to the LLM, getting the information back, and then unmasking it and use it in your application. And of course, you can scan these, you can chain these scanners for input and output. So if you need to do multiple things, you can do them all at once by just chaining them. So that's what LLM Guard enables you to do. And I think I'm almost out of time. So yeah, that was perfect timing. So yeah, hopefully this was useful to you. As I said, if you want the presentation, this is the link. And I don't have the GitHub link for some reason, but I'll just show you here. Yeah, the GitHub link is, I don't know if you can read it, but basically under my username, if you go to my username, Gen AI Beyond Basics, all my samples are there, so you can take a look if you want. All right, thanks very much.